Okay, so in this video we're going to be taking a look at practice problem 4, and this practice problem 4 is actually a reflection of the example problem 6 and 7 from chapter 2, and then there's also a hint for you or an information how you can convert the weight into a force. Okay, so that's that, and I guess we can begin here. But before we begin, let me just say why I have put this this practice problem here. The purpose of this problem is for you to see if you can apply what you have learned in this book into your thinking process. So the question, whatever the question is asking for, actually has a lot of factors involved. So even if you guess that none of those factors are relevant in this case, and just the 2D concurrent coplanar forces knowledge is relevant in this case, with that thought, can you analyze the situation? Can you tell what's going to happen? So this is what I want you to check to see if you can apply your thinking into the things around you. Apply your knowledge into your thinking to the things around you. Okay, so at first, before we begin, another thing is that if you're just looking at the solution to the the practice problems, it would be a great idea to get the book and look at example 6 and 7 before you watch this practice problem 4 solution, and the entire going through the entire book would be another great idea. So I'll just put the link to the book in the description of this video for those of you who don't have the book right now or haven't read the book. Okay, so let's begin. Before we begin, we have to place in our coordinate system. So by looking at the image, the picture, we can guess that I think you can guess where to put the coordinate. So if we put the horizontal line right over here, because it's giving us the nice angles in the picture, and then if we place the center line here, so this is going to be our coordinate system. And then for the forces, there's a guy pulling there, so that's going to be a force. There's a cow jumping or pulling, so this is going to be another force. So for the third force, let me just change the color. It's going to be the weight of the weight. Okay, so and as we know, it's going to work towards the direction of gravity, and gravity is going to go downward. It's going to pull it downwards, so the force from here is going to be downwards from the center of mass of this object. Okay, all right, so now we have our force system. So before we begin, let me just clear it out right over here. So here in the green, we have our coordinate system, and in the red, we're gonna have our forces. There you go, that's one force, that's another force. So this force is 150 newtons, and this force is 300 newtons. And then we know the angles. These two angles are 45 degrees, and then we have another force that we have to figure out. So we know that 1 kilograms is equals to 9.81 newtons, so we can easily figure out how much 50 kilograms is. So we have 50 times 9.81, which comes out to be 490 newtons approximate. So we'll just write down 490 newtons right over there. Alright, let me just erase this information from here so we have a little more place that we can work with. Alright, now let me take another color. Maybe I'll take the yellow color to divide the components of the forces, okay, the inclined forces. So one component, as it is making an angle with the horizontal, so the horizontal component is going to be our cos. So we have 150 cos 45. So this is that, and the top word is going to be same, but it's going to be sine. So we have 150 sine 45. Okay, the similar case is going to happen for the 300 newtons, so I'm not writing it down there. Now if we move on to the solution, let me take another color. Okay, at first we're going to do the summation of forces in the x direction, which are 150 cos 45, and it's going towards the rightward direction, which is positive, so we wrote it as positive. This is negative, upward is positive, downwards is negative. So this is the sign convention that we're assuming here. All right, now what else we have here? So we have another force that is the component of the 300 newtons. So we're just going to write that up here. So negative 300 cos, so that cos 45 degrees. All right, so if we do the calculations here, we're going to get negative 106 newtons. All right, now if we want to calculate summation Fy, summation of forces in the y direction, we will have 150 sine 45. It's going upwards. There you go, it's going upwards. That's why it's positive. And then we have plus 300, similarly, sine 45 degrees. And then we have this 490 newton, which is going downwards. So that's going to be a negative 490 newtons. All right, so it comes out to be negative 171.80 newtons. So we have that. Now we can draw up our little conclusion here. So let's say if I want to draw over it, or maybe I can draw it somewhere here. So here we go. This is our coordinate system, the same coordinate system we're working with. So now we have two forces, the sum of forces in the x direction and the sum of forces in the y direction. So from the sign convention here, it's a negative force, same as this one. That means it's going to be leftwards, there you go, and downwards. So these are the components. Now if we use the components to get the resultant force, which the formula is resultant is equals to summation of fx squared plus summation of fi squared. So if we do that, we get the resultant force value, which is coming out to be 201 newtons. And the direction of the resultant, if you want to figure that out, then we're going to use the theta principle. There you go, and we'll get the resultant somewhere around here. And if you want to calculate from the horizontal, let's say we want to calculate the angle from the horizontal, then it's going to be, okay, so here we have, oh sorry, I forgot to write in tan inverse. Okay, so tan inverse, since we're measuring the angle from the horizontal, so it's going to be 171.80 divided by 106, which comes out to be 58.32 degrees. So this is 58.32 degrees. Okay, even without calculating the resultant or the direction of the resultant, if we know that both the forces, one of the forces is going leftwards and another force is going downwards, then the resultant force is going to be leftwards and downwards, right? So this means that the sum of the forces are working in this particular direction, and if they're working in this particular direction, it doesn't seem like, with the limited knowledge of just applying to the concurrent coplanar forces, it doesn't seem like that the weight is coming up anytime soon, if not staying wherever it is, or it's gonna go even deeper down in this direction, right? Okay, so yeah, that was it for this video. Thank you very much for watching, and I hope you got to learn something new or see something interesting.